Okay, we're getting ready to start our second unit, biochemistry. If you would like to follow along with the notes for this unit, all the notes are in the file folder on Canvas as well as in the module. So if you click on module or click on file, you'll be able to print off all of the notes for this unit. If you need me to print you a hard copy, let me know and I will get you a copy of the notes. Now, you've heard this before several times since you were a little kid about matter. And matter is anything that takes up space and has mass. Everything is matter. So you are matter, your bed is matter, your teddy bear is matter. Everything is matter. It has a mass and it takes up space. Now, elements are the simplest form of matter, of any substance. If you have an element and it's just one type of substance, that is an element. Now, move into compounds. We have two elements that have come together to create something different. So you encounter elements or compounds all the time. Salt is a compound. Now, these elements here and here are elements that are naturally occurring in the body and in other life forms. Now, these are the most common. The carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These are most commonly found in life forms. Now, when you get to some of the other elements, they're found in trace amounts in the human body. So you can see here a percentage of the human body. But these symbols represent these elements. Same here. These are the same symbols for these same elements. Now, I know you've talked about atoms before in your other classes, or not in your middle school classes, hopefully. But let's talk about atoms now. An atom is the smallest form of an element. So if you have one atom that still has the chemical properties of an element, it is still that element. It's just one atom. So an atom is the smallest unit of matter. Now, the atom is still the element because it has all the subatomic particles that it needs to be, or that it needs to have in order to be classified as that element. So let's talk about the parts of the atom. So we have inside the center of the atom is called the nucleus. And in the nucleus we have the protons and neutrons. Now, which one would be the proton and which one would be the neutron? Right, the ones with a positive charge are protons, and the ones with no charge, you don't see anything, any plus sign or minus sign in there, that's a neutron. So our neutrons and our protons make up the nucleus of the atom. They also give the atom its weight, or its atomic weight, atomic mass, rather. And also part of your atom, you have electrons, these here. I'm not about to ask you that because that's all that's left. So we have the three parts of an atom: the proton, neutrons, and electrons. And the electrons are not inside the nucleus, they are surrounding the nucleus, orbiting the nucleus. Now, we're not going to go in depth into isotopes, but just for your information, an isotope is an atom of an element. It just has a different number of neutrons. So it doesn't change the element, it just changes the mass of the element. Now, very similar to isotopes, we have ions, and we're going to work with some ions in biology class. But with ions, the difference here is the number of electrons. Now, you just have some positive ions, which are called cations, and some negative ions, which are called anions. But we'll talk more about that when they come up more. But it is still the same element. Now, briefly, I'm going to talk a little bit about orbitals, but the orbitals are where the electrons are. Now, and however many electrons can be in an orbital depends on the energy level of that orbital. But we're not going to talk too much about that. You'll talk more about that when you go to chemistry class. Now, we're going to be talking a lot about molecules in this unit. And molecules are two or more atoms bonded together. Now, we can have molecules that have the same element, like in oxygen. This is the oxygen that we breathe, O2. Or we have molecules of different elements. And this one should be very, very familiar to you. This is H2O. We have our two H's right here and our O. What molecule is this? It is very common. You use it all the time. You should drink it every day. What is it? Now, the periodic table we are familiar with. We've at least seen it. Now, let's talk about some of the numbers on the periodic table. Let's look at carbon. Carbon is a very important element to us in all life. Now, if you notice, there are two numbers associated with carbon. One number, this number in the top corner, is the atomic number. The atomic number basically tells you how many protons are in that element. So carbon has 6 protons. This number down here is the atomic weight or mass number. And this is exactly what it says, the weight of this atom. But it really just tells you how many protons and neutrons are in a carbon atom. So there were 6 protons, we know, and there are 6 neutrons. Now, when you get into isotopes, this number change. The atomic mass will change. This will not, because if this changes, if we add protons or add protons, we move to another element. Okay, so you answer these next 2 questions. How many protons are there in an oxygen atom? And how many neutrons are in an oxygen atom? A little more about isotopes. Most isotopes are radioactive, so we're not going to be messing around with isotopes in this class, but just wanted to give you a little note about it. Isotopes, remember, have a different number of neutrons. So, and based on what we know about the atomic mass, if we add neutrons or take neutrons away, that changes the atomic mass. It does not change the atomic number. The number of protons has to stay the same for it to be that element. But if the neutrons change, or we add neutrons or take neutrons away, we've now created isotopes.